Hey physics students, so our first unit in physics is going to be about measurement. We're going to talk about how we measure things. It's kind of a really important place for us to start in physics to understand measurements. And our first target in this unit, we're going to talk about the metric system. You know, in science, we don't use our normal imperial system of units that we use in our everyday lives. We don't use feet and miles and gallons and those sorts of units that we're used to as Americans. We use the metric system, otherwise known as the SI system, right? SI stands for the International System of Units, right? Why is it SI instead of IS? Because it comes from French, right? In French, they put, the word international after the word system, so system international instead of international system. And I would say it for you, but I don't speak French and it would just sound stupid if I said it. Anyway, it's the International System of Units, the SI system, otherwise known as the metric system. And our target is to be able to use the SI system of measurement. So let's go ahead and let's take a look at some of this stuff. Okay, for a minute here, let's take a look at this map. Okay, this map shows you which countries in the world use the two major systems of measurement. And there are only two major systems of measurement. Here in the United States, we use what's called the British Imperial System. And if you take a look at the map, there is all of 3 countries throughout the world that use the British Imperial System. And Britain isn't one of them. Okay. Here in the United States, you can see on the map, we use the British Imperial System. Historical reasons. We were a part of the British Empire at one point, and so we still use their system of measurements. The other 2 countries you can see in West Africa there, a small country called Liberia uses the British Imperial System, and Liberia is historically very closely linked to the United States, so they tend to do a lot of the same things that we do. So we use the British Imperial System, so do they. And then the third one you can see over there in East Asia, Myanmar. Myanmar, after the British Empire left there, they were very much closed off to the world for a long period of time. They still used the British Imperial System. So out of all the countries in the world, there are 3 that use the same units as we do. And one of them is not Britain. All the countries you see on that map in gray use the metric system, right? And you can see this, the overwhelming majority of the world's population uses the metric system, the SI system of units. So instead of feet and miles and gallons, they'll have, meters, kilometers, liters. Instead of pounds, they'll have kilograms, right? So, and these are the units that we're going to learn about here. And since most of the world's population works in the metric system, and the metric system is better, in science, we use the metric system. Right, so we don't use our British Imperial System, we use the metric system. Now, as an American traveling in Mexico, I have some stories about the metric system there. There was one time I was in Veracruz and my shoes fell apart and I needed to go and get some new shoes, right? And I wear like a size 9. And so in the morning, I got up and I went to, there was luckily a shoe store right next to where I was staying. And I went in there and I started looking for a size 9. And I found it, and it was immediately obvious that this was a child's shoe. This was not a shoe that was going to fit me. And so, it occurred to me, I'm in Mexico. A size 9 is going to be a 9-inch long shoe. And in Mexico, they don't use inches, they use centimeters. So then I'm like, oh my goodness, how many centimeters do I need, right? I don't know. Luckily, the girl showed up, right away to help me out and find a shoe that would work. So that was a fun story about the metric system in Mexico. Another one, I was in Mexico City and I needed a belt, right? And I know my waist size, so there was a Walmart there, a Walmart in Mexico City, yeah. So I went into the Walmart and I found the belts. And I know my waist size in inches. And so I bought a belt that was the right size in inches. And I left the store. I mean, it was a pretty cheap belt, right? And I put it on. And it was so tight. And I was like, oh my God, what's wrong with this belt? And then it occurs to me, I know my waist size in inches and belt is in centimeters, right? And centimeters is smaller than an inch, so the belt was really, really tight. But luckily I made it work. I only had to wear it for about a day. So yeah, some interesting stories about the metric system. Okay, in our everyday lives in the British imperial system as Americans, if we wanted to measure like a length, we might use inches, we might use feet, we might use yards, we might use miles, right? We have several different units that measure the same thing. All of these things measure a length or a distance, right? In the metric system, there's only one. It's called the meter. And then we can modify the meter. We can use a prefix to change what we're talking about, to talk about a fraction or a multiple of a meter, right? So I could talk about a centimeter, which is based on the meter, which is 100th of a meter, right? So in the metric system, we don't have many different units to measure the same thing. We just have one unit, and then we can modify it with a prefix. And we'll talk about those prefixes a little bit later. But in fact, the fact of the matter is, in the metric system, there are only 7 units altogether. And we can measure anything using these 7 units, okay? We can use these 7 units as they are. We can modify them with the prefix to talk about, a fraction or a multiple of that unit, or we can combine them together to make what's called a derived unit. And we'll talk more about derived units in a few minutes. Let's right now take a look at just the 7 units of the metric system. These are called the base units, okay? And there's only 7 of them. You can see time is measured in seconds. The second is a base unit, and check it out. Second is abbreviated with the lowercase s. Right? Lengths are measured, like I was just talking about, in meters. The meter is abbreviated with a lowercase m. The mass is measured in kilograms. You might have been used to using grams in chemistry, but the base unit is the kilogram. It's weird because it has a prefix on it. It's 1,000 grams, but the kilogram is the base unit. Electrical current is measured in the ampere, which is a capital A. Temperature, the base unit, is measured in the Kelvin, which is a capital K. You probably remember that from chemistry. Amount is measured in the mole, MOL, and hopefully you also remember that from chemistry. And then the last base unit up there, luminous intensity, the candela, abbreviated CD. These are your 7 base units. These are the 7 metric base units. And all of the units are based on those 7, right? We can combine them. We can make derived units like the meter per second to measure a speed. We can put them together in more complex ways, like we measure force in a unit called a newton, but a newton is a kilogram meter per second. So it's made up of several base units. But that's all the units that we have in the metric system. There are 7 of them. Here you can see on this little table here, some of the metric base units. It doesn't have all of them there. There's only 5 of them along the side. And it shows you how some of them can be combined to measure other things, right? So for example, you see the top one on there, the kilogram. You see the little arrow that goes to force. You see the force is measured, you see the capital N there. It's called a newton, right? And you see the little arrow that goes away from that. The newton is a derived unit. It's made up of a kilogram meter per second squared. So kgm/s squared. So the kilogram, the meter, and the second are all part of that. And those are all base units. So you see, we can combine these base units to make other units to measure other things. Probably the simplest one you can think of is for a speed. We'll use the meter per second, right? Meter per second, meter and second are both those base units. So we can combine them in many different ways to make units to measure other things. See, in the British imperial system that we use every day, when we need a unit that measures something bigger or smaller, then usually we'll just make up a new unit, right? So if we're measuring our lengths in feet, right? Then once upon a time somebody said feet a foot is too big for me to measure this thing. I need a smaller unit. And so they made up a new unit and called it inches, right? And there's 12 inches in a foot. And why is it 12? Right? Where does that number come from? Why 12 inches in a foot? At some point, somebody said, I need a bigger unit to measure something further, right? And so they made up a bigger unit called the mile. And there's 5,280 feet in a mile. Why is it 5,280? Right? Where does that number come from? Why not just 5,000? And then why 5,000? Right? So in the metric system, it works differently. We don't make up new units to measure things. Instead, we modify our base unit. Okay? So if I need something smaller than a meter, then I might put a prefix in front of it to talk about a fraction of a meter, right? So here's a chart with some of the prefixes. There are more prefixes than you see in the chart, but these are the ones that are going to be the most important for us in our class, right? These are the ones that we'll use the most often. So if I need something smaller than a meter, I might talk about centimeters, right? So if you look on the chart there, you can see the prefix centi means 0.01, which is 1/100th, right? So a centimeter is 1/100th of a meter. So you say, how many centimeters are there in a meter? There's 100 because it's 1/100th of a meter. And you can also see on there is that same amount in scientific notation there. You can see the exponent, 10 to the negative 2. And those numbers are going to be important for us in a minute here because we're going to convert between the base unit and a prefixed unit, right? If I need a unit that's longer than a meter, right? If I need something bigger, then I can use one of the prefixes that indicate a multiple of that base unit. So maybe I'm trying to measure a really long distance, like between here and Chicago, and I might use kilometers. You can see the prefix kilo there means 1,000. So a kilometer is 1,000 meters, right? And you can see the scientific notation amount there, 10 to the 3rd power. Now we're going to use this chart, we're going to use these prefixes, and we're going to want to be able to convert between the base unit and a unit with one of these prefixes on it. So let's take a look at how to do that. Real quick, I want to draw your attention to one of these prefixes in this chart. And you can see right up here, I've highlighted it in yellow. It is the prefix micro. Okay, all the other ones are abbreviated with letters you know and understand, right? Giga is a capital G, mega is a capital M, and so forth. But this one here, micro, is abbreviated with a different kind of letter. That is the Greek letter mu. The Greek letter mu, and it means micro. It means 1/1,000,000th, or 10 to the negative 6th. When you draw this number and you write it, you can see it in type there. It looks kind of like an upside down H with a little hook on the bottom. When you write it, when I write it, it tends to look like that. So just so everybody's familiar with that letter, so that we understand what I mean when I write this is the letter mu, and it means 1/1,000,000th. Okay, so over the course of our physics class, we are going to take some measurements and we're going to do calculations with them. We're going to do lots of calculations with our measurements. Now, when we do a calculation with our measurements, it needs to be in the base unit. Okay, but we don't always measure things in the base unit because sometimes it's inconvenient to measure things in the base unit. So we're going to need to be able to convert between a unit with one of these prefixes and the base unit. So maybe I want to measure something that's, I don't know, this big. I'm not going to measure it in meters because a meter is like this big, right? I'm going to measure it in centimeters. But then if I need a calculation with that number, I'm going to have to convert it into meters. So we need to be able to do that. Let's take a look. Here's an example problem. It says convert 12 centimeters to meters. So here's what we're going to do. If you took chemistry with me and you remember the unit on stoichiometry, this should be very, very easy. We're going to go about this very much the same way, only the problems are going to be really short, right? Much shorter than a stoichiometry problem. So my advice for approaching this kind of problem is what we're going to do is we're going to take that number that they gave us to start with, and it said 12 centimeters. Okay, so I'm gonna write down 12 centimeters, and I am gonna put that as a fraction. I'm gonna put 1 in the denominator, just 1. Okay, and then I'm gonna multiply, and I'm always gonna multiply, and I'm never gonna divide. Okay, just multiply. And I'm gonna make a second fraction here. Now to figure out what goes in the second fraction, I'm gonna look back at that chart that we were just looking at a minute ago, okay? And I'm gonna look at the prefix that's important for what I'm doing. Find my chart, here it is. Okay, so this is centimeters. You can see the prefix on there is centi. So I'm gonna go to my chart and I'm gonna find the prefix centi, and I'm gonna see how much is centi, how much does that mean? And I look at my chart, I find centi, and I can see that it's 0.01 or 10 to the negative 2. You can work with either number you feel more comfortable with, right? You can work with the standard number, 0.01, or you can work with the scientific notation number, 10 to the negative 2. Using those scientific notation numbers are gonna make it a little bit easier to set up the problems, right? So I would encourage you to use those numbers. If you're not that comfortable with them though, you can use the standard number, it'll still work. I'm gonna use the scientific notation number. Okay, so I've looked up centi. It means 10 to the minus 2. And that's 10 to the minus 2 meters. That's that many of the base unit equals 1 of the prefixed unit. Okay, so 1 centimeter is 10 to the negative 2 meters. And I'm gonna put each of those numbers into this fraction, okay? So 10 to the negative 2 meters and 1 centimeter. Think about this for a minute. Where should I put the 1 centimeter? I have a centimeter on the top of this fraction. I'm gonna want a centimeter on the bottom of this fraction so that they cancel out. So I'm gonna put the 1 centimeter on the bottom there. And the other number, the 10 to the minus 2 meters, is gonna go on the top. Now if you look what happens, I have a centimeter on the top, I have a centimeter on the bottom, they cancel out. And that means that my answer is left in meters, which is what the question asked me to find. So that's good. Now all I have to do is work out the answer. So I have 12 times 10 to the minus 2, and that is 0.12, and my unit is meters. If you prefer to have it in scientific notation, you'd have 1.2 times 10 to the minus 1 meters. So 0.12 meters or 1.2 times 10 to the negative 1 meters. If you're in the honors class, you should definitely be able to do the scientific notation. If you are not in the honors class and you want to use the standard number rather than the scientific number, it's perfectly acceptable. So there's an example of how we do this kind of problem. Okay, let's have a look at one more example here, and this one is going to have some scientific notation in the problem. Okay, this one, it says convert 1.2 times 10 to the 4th meters to kilometers. Okay, so just like the other problem, what I'm going to do is I'm going to start with the number they gave me, and I'm going to put it in the top of a fraction. So 1.2 times 10 to the 4th and that's meters. And on the bottom, I'm just going to put 1. Okay. Now, they wanted me to convert this to kilometers. So I'm going to go to that chart, and I'm going to look at the prefix kilo. Kilo. And if you look at your chart, you can see kilo is 10 to the 3rd power. 10 to the 3rd meters is 1 kilometer. It's always 1 of the prefixed unit and that many of the base unit. Okay, so I asked myself, which one do I want to put in the bottom here? It's 1 kilometer and 10 to the 3rd meters. You can see we have meters up here. So down here, we're also going to want the meters. So it was 10 to the 3rd meters. We'll put 10 to the 3rd meters here. And then the other number, 1 kilometer, 1 of the prefixed unit, is going to go on the top here. And you can see this is different from the last problem. In the last problem, we had the prefixed unit here and the prefixed unit down here, and then we had the base unit up here. This one, we've got it the other way around. We have the base unit, and the prefixed unit. Okay. So now you can see my meters cancel. I'm left with kilometers, and that's what the problem asked me to find. It asked me to find kilometers. So now I'm in a good place. All I have to do is work out the problem. So I have 1.2 times 10 to the 4th divided by 10 to the 3rd. If you remember your exponent rules, all we have to do is subtract those exponents. So I have 1.2, and then 10 to the 4th, 10 to the 3rd, 4 minus 3, 10 to the 1st. And this will be in kilometers. And there is that. If you prefer, this particular number can just as easily be expressed in standard notation. It probably makes more sense to express it in standard notation. That is 12. Just move your decimal point one place. So that is the same as 12 kilometers, which is probably the more convenient way to express that particular one. So there is another example. Alright, so there is a little bit about the metric system, the SI system of measurement, which is going to be important for us as we go through physics here for us to know and understand. Hopefully that helps us to be able to use the SI system of measurement. So until next time, take it easy.